Right, this is the 2000 watts Smps, which is of the LLC type. Okay, this is the input filter here. Here we have the input capacitors. We have 4 capacitors with a capacity of 680 microfarads at 450 volts rating on the input. Here we have the main oscillator board, which is a pin header and can be detectable. The oscilloscope here is coupled via a 2-turn coupling loop. I have 10 turns in the primary, so we can make out what is going on over there. This is the heatsink for the 2 regulators that I have. I have a 15015 regulators. This is the main output, and this transistor will control the revolutions for the fan according to the temperature on the IGBT heatsink here. And we have an auxiliary power supply, okay, which is switch mode as well. And basically we have these 2 wires here, which when connected together will shut off the power supply, and there I'm going to fit with them a thermal sensor, a bimetal switch, which is normally open, and I will have one with the sandwich between the soft start resistors, and another one will be hooked in parallel with it on the IGBT heatsink. So that will take care of my thermal protection. As one can see here, I have 2 diodes. Only one can be seen at the moment. Maybe get some more light. The red one will represent the thermal overload, and the orange one will represent when overload is due. Okay, up here I have an oscilloscope which is hooked down here, which will be monitoring the waveform at various loads. Okay, the Smps is started up now. That is showing the input voltage. This is showing the input power. We have a light load at the moment. That is the output voltage. Okay, and this is the output current at the moment. We have various loads here. I have switchable halogen lamps that I can switch on one by one. Okay, and over here I have filament heaters that we will be loading the Smps with it. Okay, we are going to test the thermal overload first. Okay, and the 2 lamps will light up. One is showing protect, and the red one is showing the thermal. You could hear the fan revving and then slowing down again, and that's due to the kickstart I have built in here to help the fan take a kickstart as soon as the Smps is switched on. Right, so I'm going to put a load here now, which is rather high, and here goes. That's the input voltage. That's the input wattage here. Okay, input power. This is the output voltage at load, and this is the output current at the moment. It is 10.6 amps. Okay, I'm removing the load again. Now we load a bit more with the halogen lamps here. Alright, and I'm going to add more load. We have 2 amps there. The input power. Now it's running at 12 amperes. Alright, the output voltage is 150, the input voltage is 222. Okay, we'll add a little bit more up to the peak, and we're running at 13 amps now, 150 volts, That's the input power, it's 2000 watts, and that's the input voltage. Okay, reducing the load again. This is the power supply on startup facing a 1.5 kilowatt load. Here goes. There we are. No problems at all. I have the load over here and the lamps. That's it. Right. This time I am going to overload the power supply here, and you will notice something. You see the protect LED comes on, everything shuts off, and then it tries to start again. Okay, but the load is still present, so it doesn't. I'm going to remove the load now, the short circuit I mean, and the power supply resets itself. Okay, here we're running at load again. This time we're having 12 amperes. Okay, that's the output voltage, that's the input wattage, and that's the input voltage. Okay, with this kind of load at 230 volts, I was getting over 2 kilowatts. I'm a bit under at the moment, but I don't have the extra load that I'll be needing to cater for a little bit more load. This is the temperature of the IGBT heatsink, which is quite modest, and the temperature of the diodes here. This is the heatsink for the diode, mind you. And everything seems to be alright at this current. Okay, I remove the load again. And that's it. I hope you like it.